Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn angle of elevation. At the end of this lesson, you will be able to correctly define and give examples about angle of elevation and accurately solve problems involving angle of elevation using trigonometric ratios. In my previous video, I discussed already the 6 trigonometric ratios. Let's start. Let's learn first what is an angle of elevation. Angle of elevation, it is the angle between the horizontal axis and the line of sight when an observer looks upward. This line here is the line of sight and this is the horizontal axis. Now the angle formed here is the angle of elevation. This is where the observer located. So from the campsite, the observer looks at the top of the mountain. And this mountain is the object. Now this line here, again, is the line of sight. And we have here the angle that is being formed is what we call the angle of elevation. Let's try some examples about angle of elevation. First, at a certain point, 62 meters from the base of your mom's office building, the angle of elevation of the top of the building is 70 degrees. How tall is the building to the nearest hundreds? First, we are going to illustrate the problem. This is the building and we are going to find the height of the building given the distance from the building to the location of the child is 62 meters. And now it forms an angle of elevation that is 70 degrees. And we are going to find the height of the building given the angle of elevation and the distance from the building to the observer. Second step, we are going to identify the trigonometric ratio that can be used. Because we can find the height of the building using the trigonometric ratios. And we are to find which trigonometric ratio are we going to use. Okay, consider the position of the given values with respect to the given angle. So this is our viewpoint here, or the angle theta. And this side here is the opposite side, which is the height of the building. And this distance here, which is 62 meters, the distance from the building to the observer, that is the adjacent side. Take note, the involved sides are the opposite side and the adjacent side. So the only trigonometric ratio that involves opposite and adjacent side is the tangent ratio. So we are going to use the tangent ratio to find the height of the building. Using this formula, tangent theta is equal to opposite over adjacent. Solve for the height of the building. This is the illustration. Now, since the theta is equal to 70 degrees, we will be using that. That is, tangent 70 degrees is equal to opposite over adjacent. Our opposite, since we don't know yet, that's the height of the building, we let it be h. Over the adjacent, our adjacent is 62 meters. So we have there, tangent 70 degrees is equal to h over 62. Then, multiply both sides by the denominator, which is 62. So we'll multiply both sides and this will be cancelled out. So the remaining here is h, or the height. Then for the left side, that is 62 times tangent 70 degrees. Now, tangent 70 degrees, that is 2.7477. And we can switch them up. So we have here h is equal to 62 times, this is the tangent 70. We simplify it already using calculator. 2.747477. Now 62 times this one is approximately 170.34. So our h, or the height of the building, is equal to or approximately 170.34 meters. We use the word approximately um, since we rounded off to the nearest hundreds. Example number 2. A 10-feet flagpole casts a shadow of 18 feet. Find the angle of elevation of the sun. Round your answer to the nearest degree. Okay, we are going to illustrate first the problem. This is the flagpole, which is 10 feet high. And then that flagpole casts a shadow of 18 feet. Of course, the shadow must be here. So this is 18 feet. Find the angle of elevation of the sun. So we suppose this is the end of the shadow here, and we suppose this is the observer. Then we have to make a line, which is the line of sight from the top of the flagpole to the observer, and it forms an angle here, and this is the angle of elevation, since and we don't know yet what is the measurement of that angle. So we are going to find the angle of elevation. Second step, determine which trigonometric ratio is appropriate to use by referring to the given angle. So the given angle here, or the angle of elevation, is in here. Now the opposite side is the 10 feet, or the height of the flagpole. And this side here, the shadow, is the adjacent side. So again, the involved sides are opposite and adjacent. So we'll be using tangent theta is equal to opposite over adjacent. So we have to observe what are the given sides so that we can identify or determine what trigonometric ratio are we going to use. Third, solve for the angle of elevation of the sun using the formula tangent theta is equal to opposite over adjacent. We don't know yet the angle, so we let it be tangent theta is equal to the opposite side is 10 feet and the adjacent side is 18 feet. So we have 10 over 18, and 10 divided by 18 is equal to 0.55555. So we have tangent theta is equal to 0.555. But we are looking for theta. So we have to get the inverse of the tangent of 0.555 to get the theta. Theta is equal to tangent inverse times 0.555. That is, using the calculator, we have theta is approximately 29 degrees. And that's the measurement of the angle of elevation. And now I'm done with my discussion for today. Now I want you to answer these two problems under individual practice. And I want you to comment your answers below so that I can check your answer if it's correct. First, find the length of the shadow casted by a 10-foot lamppost when the angle of elevation of the sun is 58 degrees. Express the length to the nearest tenth of a foot. Second, you are measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height of the tree to the nearest foot. And that's all for today. Thank you for watching.